Greetings and welcome to the Political Ferret Show.
When you concern yourself with philosophy, you will very likely stumble over an implication that you really do not like. Most people tend to ignore it, but I feel a strange attraction to those things. Today we're talking about such a thing, and I gave it a lot of thought, and I formulated an hypothesis that I do not like, but the more I think about it, the more it makes sense, and that makes this thing interesting for me. But I want to be very blunt here. If you see a logical error, I would be more than glad to hear about it in the comment section. Furthermore, I simply can't test this hypothesis. We're talking about nothing less than a scope of a dissertation to conduct and analyze the experiment that I will propose in this video. So if somebody wants to do that, feel free to do it. So what do I propose? I propose a variation of the experiment of John B. Callahan that led to the observation of the behavioral sink. To recap for those who don't know it, between 1958 and 1962 scientists wanted to find out how overcrowded systems react. For that they created a giant cage for mice, in which they had anything that they would ever need. Food, water, nesting materials, no predators of course, it wasn't mouse utopia. And this word stuck with us. So the question the scientists were interested was, if we give the mice enough food, water, nesting material and so on for, let's say, 1,000 mice, how close will they come to this limit? The expectation was that the population would overshoot this maximum, some then would starve, and then the population would stabilize somewhere below 1,000. But the question was how close? 500, 800, 999, or even 1,000. The interesting thing is that the mice did behave completely differently. They never came close to this theoretical maximum. The mice started to change their behavior, especially in mating and in regards how they behaved to their offspring. Females started to become way more aggressive, started to fight males, neglect their offspring, while a lot of the males become less aggressive and did not even try to win females over by fighting other males. All they did was grooming themselves. So if you took then a mouse out of this environment and confronted them with a normal mouse, they did not change back to normal. They were absolutely uninterested in mating. The most accepted explanations for this is that mammals are programmed to not overpopulate. You see, if locusts have 10 times the food in 1 year, they produce 10 times the egg, which results then in a catastrophe in the next year because there are way too much locusts. And not only that, the following year will be less plentiful, you also have then way more locusts, and this is bad for the environment, for the people, and also for the locusts. So it seems that mammals have a tendency to not use all the resources up, overpopulate, and then collapse in the next year. If the living conditions are good, we do something that insects, for example, do not do. We reproduce less. We have less offspring in anticipation that the next year will be not as good as in the next year. And this is not a conscious decision. This is purely instinct in the end. But what if the low never comes? What if we stay in an utopic situation? Well, then we are in the realm of the behavioral sink, and the population collapses because something deep inside of our brain tells us that everything is way too good to be true, and having 20 children would be a bad idea, although we could do it and there are enough resources, but something tells us it's a bad idea. And while people in actual bad situations, they just do not come to the same conclusion. They think that having 20 children is a good idea. So recently, which means in the last 10 years or so, some people use this experiment and the conclusions to draw other conclusions back to us humans, pointing out that feminism or the MGTOW movement or birth rates in the West and so on have an uncanny similarity to what happened with these mice in the Mice Utopia experiment. And so let's see, the last big baby boom we saw in our own history occurred in a time when the world was devastated, and the better the place got, the less the population did grow. So The idea to counteract this, now that we are, to a certain degree at least, collapsing, is migration. Just take people from places that breed faster to places where they breed slower and keep the population constant. But what I now suggest is that the migration itself might stop the collapse. In other words, if you have migration, the population in the utopia that would collapse does not, and therefore needs less migration, as if when they completely collapse and have to be repopulated again. And that sounds complicated, so let's talk in pictures. Here we see a schematic of the Mars Utopia setup. The dimension doesn't matter. All that matters are the proportion of the cages in the end. So, since the experiment was repeated several times, we know what will happen if we start the experiment. The mice will change their behavior and then they die out. So what we do now is we place a secondary cage around the first one. The secondary cage, this is the addition in the end, shall be at least 2 times the area of the Utopia cube. But food, water, nesting material and so on shall be only half of the supply in the Utopia. This means that we have way more space but way less material to live, about a quarter in the end. So the result is that there is a less convenient lifestyle, and therefore a way lower theoretical population density. And for good measure, we just drop a cat every day inside there for 5 minutes to add some extra stress and to make it really dangerous to live there. So now, the border between the normal world and the utopia shall be very easy to traverse from the utopia to the normal world, but somewhat harder in the other direction. That means it should be easy to get out of the utopia, but hard to get in again. This can be realized by a spring-loaded door on the one hand and some sort of labyrinth or obstacle course on the other side. What I would now expect to observe is that there will be mice migrating from the utopia for a very simple reason. Those who leave the utopia will try to find a way back because it's obviously better where they came from, and then they will never try to leave again. On the other side, some of them in the outskirts will, just by sheer chance, find a way to the utopia, and then they will stay because it's obviously better there. I don't think that the outskirts will ever be vacant. I mean, if stressed enough, they will never experience the behavioral sink effect. If they do experience this effect, well, the setup is wrong and you have to send the cat way more often in to stress them more so that they feel stressed enough to behave like normal mice do. This means if the utopia does collapse, it will be repopulated from the outskirts, and this is pretty much what the proponents of unhindered migration bring as their main argument, that we need this migration, otherwise we collapse. But what I suggest is that those mice who were born in the utopia but made one excursion to the outskirts, again by sheer chance perhaps, and find their way back, will have, and this is the theory that I can't prove, but I think it needs to be checked, I think they will have a reduced likelihood of falling into the behavioral sink. If they experience hardship just for a short period of time, I suspect that the effect of the behavioral sink will be at least mitigated, or even completely cancelled. On the other hand, if you better the situations in the outskirts, which means primarily, do not let the cat in, give them more food, water and so on, I suspect that the whole setup will collapse, because then the outskirts are the same thing as the Mars Utopia. And this brings us to the final, somewhat dire hypothesis. Let's assume that the behavioral sink is something that humans experience, and that some of those things we observe in the West are a more or less direct result of this effect, which is supported by the fact that richer families in very poor nations also tend to have less children. The mainstream hypothesis is that this has to do with rational decision making, but what if it is not? What if this is what we simply do? What if this is an instinct? What if we are programmed to reproduce less if we're doing too well, like mice obviously do? If this is correct, we need as a species some of our human groups to live a dangerous and uncomfortable life. Because if we live all in luxury, we would die out because we all would experience this effect. We know that these mice who were raised in the utopia and then migrated to another setup remained in the behavioral sync modus. We tried that in the past. But the question is, if we can circumvent this, if we take, or if a young enough mouse makes his journey by chance in the end into the real world, experiences hardship, and be this only for a short time, and then finds its way back, if this does something with the mouse, and if this mouse that is then in the normal modus has some influence to the other mouse who are socialized within the utopia, because they do not behave based on the behavioral sync, but differently, and therefore can influence mouses that never were in the outskirts. So if one mouse that experienced hardship can change the whole setup, or in the other way, that one migrant who experienced this hardship then changes the mice that are otherwise completely socialized in the utopia. If this would indeed be the case, it would be a good explanation why children out of working class families, who tend to feel more hardship, have more children than children coming from money. I think my point here is that there is a good reason to believe that very successful societies collapse, as they did so often in the past, pretty much because they made life too easy for their fellow humans, and then began to show signs of this behavioral sync effect which weakens them, which then led to them collapsing, or being crushed, or being conquered, and so on. So to recap the whole thing, we know that some, if not all, mammals are susceptible to the behavioral sync. And I'm fully aware that we are not in danger to make the whole world an utopia overnight. But some technologies have this ability to bring us way closer to that. And this might be, and this sounds strange, but this might be dangerous for us as a species. So the question is now if this all could lead to the downfall of our species. Not atomic bombs and climate change or something like that, but our unlimited access that is then available to everyone. And this is an interesting philosophical question, I think. So, thanks for watching, and I hope you have a wonderful day.